Hi, how's it going? My name is Austin. I am an undergraduate computer science student at the University of Texas at San Antonio, and today I'll be walking you through my research project on hand pose estimation. Hand pose estimation can be thought of as a modeling the various parts of a human hand. Essentially, we want to calculate the number of parts on a given hand and mark and track them using what is known as landmark points. These individual points allow us to track and simulate a hand movement. With this, we can determine if we are grabbing an apple, grabbing onto something, or an object, or making a gesture. Most recently, there has been new development in the space with the introduction of low-cost depth cameras to evaluate deep learning models techniques. With this, we can broaden our reach of technological innovation in the space. Today, we can contribute these new developments to applications consumers use today, such as hand gestures in cars to turn down the volume, augmented reality such as HoloLens or the Kinect, where we can track hand positions in 3D space, and televisions where a simple hand gesture can turn off or pause TV. Nevertheless, within this space comes with its own sets of challenges. The hardest part about tracking someone's hand is getting the right output given any number of frames. A frame can be thought of as a person's hand after it has been rendered. Depending upon how the person moves their hand and what is captured by the camera can greatly impact our results. We can capture any part or number of angles. Some can be clumped or deformed, which make it more difficult for a model to process. A basic model of a deep learning network used in hand pose estimation is CNN, otherwise known as a convolutional neural network. It is most commonly used for image classification and identifying objects and categorizing them. Within a CNN, you have layers that are connected to only neurons close to itself and have the same weight. Within this type of network, you have many dense layers to help with the processing of images and pooling layers that will help maintain the dimensionality we wish to keep. You also have a fully connected layer and some activation functions on the way, such as ReLU or sigmoid. This model alone will be enough to determine the number of connected joints in a human hand, as long as the data is clean and not complex. In reality, this will be undesirable, as the chances of this occurring are slim. Therefore, newer methods needed to be deployed on top of CNN. For instance, researchers at Frontier Labs combined several frameworks to help with the hand pose estimation model. Three frameworks were used: Palm PoseNet, which identifies joint locations; AngleNet, which measures each joint point given a certain angle; and LengthNet, which estimates the length of each joint segment. All of which were combined in a 2D convolutional layer and a symbol layer to display the joint locations. Researchers at Microsoft developed an internal model that focuses on segmenting out several parts of the human hand into three categories. They used the shape, position, and full dimension of the human hand using heat mapping technology, kind of like LiDAR, where the image is always being processed. Also, Google researchers have developed a similar open source library known as MediaPipe, a program I will later discuss, which was used in my program to use two machine learning models working together to produce its result. Google used a palm detector that maps out the image imprints and a hand land marker that returns a high fidelity landmark image. Within the program I developed, I chose to use MediaPipe, as it has a much more lightweight and accurate runtime than other similar frameworks, such as OpenPose. This library, coupled with OpenCV, made up the most of my program. OpenCV was used for rendering images into RGB format, as well as handling various tasks such as image loading and processing. MediaPipe hand pose model was used for rendering the model and processing landmarks given the dataset. In this project, we used the open source freehand dataset, which comprises of more than 32 hand positions. MediaPipe is a out-of-the-box program that does not require its weights to reset after each runtime unless the confidence rate was changed. One of the biggest concerns when developing the program was loading and shifting images. MediaPipe requires images to be flipped onto its axis, as direct processing of an image is not allowed. There were also issues found when loading images into the model. It was determined that loading image files locations and then processing the images for the model was the best result, as hot loading was not an option. I was able to get 70% of the 200 images observed correct, while more complex images were not registered. I decided to keep the confidence rate to 80% as this gave the best results. Setting the confidence rate to a higher number would give fewer stable results, and the same when the value is lower. In conclusion, I was able to produce landmark from the images in the dataset and even more complex images when a foreign object was inserted. Thank you for your time, and I hope this helps you understand my program, and feel free to review or download the program and play around with it with some of the functions and methods. Thank you.